Okay, thank you. Thanks all for coming out here. This is the second fireside chat of this afternoon. We just had one with 3 founders of companies. Fortunate they were really technical, so we had great technical conversations as well. We'll have now conversations with 3 CTOs who are actually also founders of companies. So probably we'll have similar style of conversations, but we'll dive maybe a bit more deeper into tech. In case you don't know me, I'm Werner Vogels. I'm also a CTO, in this case from a bookshop around the corner. Can I invite Seth Proctor of NuoDB on stage? Hi, Seth.
Great
Pleasure.
to see you.
Have a seat, man.
Thank you.
Yeah. NuoDB.
Yeah.
Man, who wants SQL?
Who wants SQL? Everyone. SQL's the new, like, NoSQL.
Okay.
SQL's back in. It's totally cool.
Yeah. Okay, so give me the 30-second pitch on the kind of stuff that NuoDB does that other SQL databases don't.
Absolutely. So NuoDB is a SQL database, fully relational, kind of all the gnarly, heavy lifting, multi-way joins, big transactions, complicated analytics that you could do with an Oracle or something you can do with NuoDB. But it's designed around a fundamentally new peer-to-peer distributed architecture. So it's designed to scale out on demand. It's designed to use only the resources you need to run multi-region and to be active everywhere so that you can solve latency problems, data residency problems, kind of other interesting things people care about. Okay, that's cool. Multi-region. First of all, you guys launched a new product recently? We did, yes. a new release of our product last week. And that had very specific features. It did have very specific features, yes. In the same vein of who needs SQL, the people who need that get really excited when you say you've updated the SQL optimizer, new indexing capabilities, optimizations for running hybrid models to be able to do real-time analytics on your operational data, some really core architectural features like that, yeah. Okay, you guys are also well known for sort of the policy-driven automation stuff. Absolutely. So tell us what that means. To me, what it means is, as you're building increasingly complicated systems today, the way you make them scale is by increasingly not specifying every detail of how you do deployment. And that's a lot of what I saw in your keynote this morning, is trying to describe containers, automation, how you assemble things declaratively. And so we're really focused on how do you run distributed architectures by specifying your SLAs, by specifying the problems you're trying to solve, and let us take care of running and maintaining that and kind of using resources as effectively as possible for you. Okay, so tell me about the SLA side of things. So what does that mean? On which dimensions do you give SLAs, or on which dimensions ask customers for SLAs? So today, the SLAs are focused more on questions like how many independent points of redundancy do you want? Kind of how large are you willing to let a database scale before you want to cut it off because your budget's limited? What kind of instances do you want to run, because you may be running in a mixed model and you want different kinds of instance types because you're solving different problems on the same database. As this feature matures, it will let you specify things like what kind of transaction rates do I want, what kind of security policies do I need in place, where do I need to make sure things are running or make sure things are not running. One of the things you did recently that's awesome is you opened a data center in Frankfurt. And anyone who cares about international data security issues, the canonical example is always German citizens' data, and now we're actually doing those demos. So that's really cool stuff. Okay, we'll get back to that in a minute. But SLAs in your case mean it's more about performance and how you, let's say, automate things, much more than that you would do different engineering for particular customers. Yeah, I mean... Because I've always, in our case of SLAs, you only get one SLA because you build this for 100% availability. You don't build it for 99.95. You build it for 100%. And so everybody gets the same SLA because technology-wise you don't do anything else. SLAs are much more often a legal document than that they are an engineering document. But in your case, SLAs are true engineering sites because of, or at least it's performance specifications. Yeah, exactly. So in our system, the developer sees a single logical database, no matter how it's running. So there's no sharding, there's no kind of active passive models, it's just a database. So operators are free to decide What are they trying to solve? What are they trying to optimize for in terms of resource management, in terms of failure models, and how do they focus on saving costs?
Okay. Now, okay, coming on to the interesting topic of data residency, but
Yeah.
why is that such a specific thing that you guys address? Is there architecture, is there engineering that helps with that?
Yeah, I think a lot of it is in our architecture. What's been really interesting to me over the last few years is as people are building systems that are running across multiple geographies, they're increasingly concerned with what happens in terms of the legal issues in those different geographies. And so Germany's the great example because German laws are so specific about what can happen with their citizens' data. And so when you want to provide a service that is globally available and appears to have the same information and the same capabilities everywhere, you have to think about how you do that while at the same time protecting all those individual laws about where things live on disk. And then later being able to prove through audit that you actually maintain those laws. And that's something that our architecture is really uniquely suited to be able to support.
Okay. Tell us about what there is in that specific architecture that is there to help that.
Sure. So the architecture is built around a peer-to-peer model. So there's complete independence. There's no master of anything. There's no central point of coordination. Those peers are running in one of two models. They're running either in memory or they're focused on disk. The in-memory peers are where we're having SQL clients connect to the system, driving transactions, where we're enforcing kind of all the consistency and atomicity rules. But then we think about data durability as a separate concern. And so we're really not optimized to worry about IOPS on disk per se. We're also not really concerned about where the data lives on disk relative to where you can actually drive transactions. And so for us, it's much more about how do you bring things into caches very efficiently, have these peers work together well, and then separately you worry about where the data may live in one or more locations on disk.
Okay, so in a multi-region model, what are your biggest challenges?
Well, I think there are a couple big challenges. One of them is just cutting down on complexity. I mean, it gets so complicated because often multiple regions means multiple people, or in large organizations means multiple teams that are administering the same systems. And so we're very focused on trying to simplify the tools, simplify the APIs, make that easy to work with. Certainly, from a systems point of view and an architectural point of view, we have all of the classic challenges of distributed systems, focusing on what happens in the failure modes, trying to minimize the amount of communication on the network so you can really take advantage of virtual systems, you can take advantage of public infrastructure and really run efficiently. And so that's a lot of asynchrony, that's a lot of optimism in our system, that's a lot of understanding how to reason about the system at all times so when failures do happen, you know you're still a consistent database.
So given all that complexity, does that mean that you run the databases for your customers? Or is it that you hand over the software to your customers to run their own databases?
So we hand over the software to our customers, and they can run it anywhere. Obviously, we encourage them to run it on Amazon. It's a perfect environment for software like this. But we hand it over to them, and that's part of why we're so passionate about making it as simple as possible to work with.
Okay. Tell us what a typical deployment looks like. Is there a typical deployment?
Right, I was going to say...
I mean, also on the AWS side. I mean, you guys use C3 8XLs at the minimum, or...?
In the vein of the last 2 days' keynotes, atypical is the new typical, okay. Or the new norm or something. No, I mean, I think there is no typical deployment. I think there are customers who come to us that are looking to do some very simple things just around redundancy, around being able to run active in a couple availability zones or in a couple regions for small throughput, but just reliability. We have customers who talk about kind of familiar workloads. At the end of the month, there's a lot of activity. At the end of the quarter, there's a lot of activity. When a game starts, there's a lot of activity. You know, there are all those events when you on demand want to spin up a lot of resources and then shut them down when you don't need them.
Okay. So what's a typical instance size?
The typical instance size varies a little bit, and that's part of what's nice about this architecture, is that you can actually run with mixed instance sizes. Okay. Certainly, the R3 instances are great for us because those are memory focused, and so we're really able to do things on that memory-centric side of the architecture really efficiently, and then we can spin up different instances that are focused on storage, or if we're trying to do analytics at the same time we're doing operational data, we can spin up I'm really eager to try some of the new C4 instances and see what you can do with those.
Okay, cool. Especially because they are network optimized to read and write towards EBS, so that's actually great architecture.
Yeah.
Some people that have built, let's say, global spanning SQL servers had to butcher SQL to be able to make that work.
Yeah.
You guys have not done that?
We have not done that. No, this is real SQL. We have customers taking incredibly complicated applications off of Oracle DB2 SQL Server and just putting them onto our system and they're working.
Okay. So let's talk a bit about your company, just from, say, a founder perspective.
Sure.
How big are you guys?
We're about 60 people at this point, which for a startup feels great. For a database, it's tiny, but we're growing.
Okay. Something that I've asked the founders in the previous session is, what's your ratio of salespeople versus engineers?
Our company is very heavily engineering focused.
Yeah.
I would say more than half the company actually is focused on engineering.
Okay, cool. You guys took investment?
We did, yes. A couple rounds of investment, yeah.
And so, really congratulations on
Thank
that,
you.
by the way. And especially because it's a former founder of Informix, I believe, that actually supported you guys there. What are you using the money for?
Well, we're using the money in large part for continued development of the core. We're building out some really interesting capabilities going into 2015 that are really kind of stressing the limits of what a traditional database can do. We're also using it to be able to grow out, as you said, kind of that sales and marketing piece as we focus on increasing number of enterprise and sales opportunities for the company. Yeah.
Given all the announcements that we've made in the past, let's say, 2 days, is there anything particular that excites you?
Well, there are a couple things that excite me. I would say Lambda is just awesome. I mean, I saw that announcement this morning, and I just got giddy. I mean, I'm really, really looking forward to playing with that. I think that kind of asynchronous programming is absolutely how we think about design, and it looks really cool.
Okay,
it looks really cool.
Seth, thank you very much for being on stage here.
Werner, it's my pleasure.
Thank you for talking with us.
Thank you.
Really
enjoyed it.
Great. Thanks.